Okay, let's go then. So the main thing to know is that the instructions for building the triple cones comes from Mike's paper, which is on academia, and it's called Triple Cones Cancel Vac Symptoms. So anyone wanting to build the cones, it would be wise to go to that paper first and having that copy, because that actually gives all the information. I was able to build them very successfully just from the information there. But what I'm going to do today is just go through the practicality of it, because there are certain things that can be simplified when you've done it on a practical level. So initially, Mike was saying that the first triple cone would be built using one of these paper cones. So I actually did some of those. There's one of them. But later, it was discovered that the pine cone model was a more powerful version. So the pine cone molds, there's one of them there. They're easily available. They're actually baking molds, but they're rubber and they're easily available. All of this stuff is very easily available off the web. To actually create the mixture for each of the three cones, the basic cement that I use is this one, which is this is from Screwfix, and it's called it's just rapid set cement. And most towns have a Screwfix, and so you can actually pre-order the cement online. A tub like that comes with 2 of these bags, so that's actually ready. So the 3 ingredients for the main composition for each of the cones is the cement I've just shown you. The second one is the iron filings. So the iron filings, the best kind to use are from a machine shop. So that's the second ingredient. I'm going to show you the most basic form of triple cone way, so you can get building them straight away. What we'll do, I think, is I'll just go through. There are 3 stages for each, so a stage for each of the cones. So the water that I use, I mean, this is just a small sample really, but this is crystal water. So crystal water is it's local spring water that I use. There's a local spring, and I go along there with some containers and I get the water, and then I like to stand the water in a glass vessel rather than a plastic one, and put some clear quartz crystal in there. I tend to leave it for about 2 weeks.
Actual GANs is a really good idea to put in the goodies, because it's microtubules.
Right.
And it creates piezoelectric spins the same size of our DNA.
Okay.
And it's superconducting. That's why it works. This is ideal. Some people are going to wait 2 weeks, whereas the colloidal silver water, you can make it quite quickly. Dissimilar metals wound together, like we use copper and zinc BBs. And where the 2 dissimilar metals touch, there's a potential difference there between the sizes of the crystals in each metal. About the quickest and easiest to do is 2 dissimilar metals wired up, preferably in a tensor ring, but it doesn't matter. You just put that in with the goodies, and you've got a forever source of piezoelectric energy.
So the mixing of the material, all you really need is a builder's bucket like this one, and I found the best tool to mix it with is a fairly robust scraper like this, because you can mix it pretty thoroughly with one of those. So you initially add the water. So the water goes in first, and it's better not to overdo it with the water. So probably just having maybe, well, it depends on which process you're doing. If you're going to do the first process, which is to do the 8 pine cone molds, probably half an inch of water in the bottom of the bucket would be enough. And then the ratio of the cement to the iron filings it's 30% of the iron filings to 70% of the cement. So the iron filings go into the water first, and then the cement is added gradually. When you're adding the cement, it's quite dusty, so it's worth wearing a mask like this, or even some, you could wear some eye protection as well. And so the consistency of the mix needs to be, it needs to be able to be poured, but only just about. So it's a similar consistency to builder's mortar, really. And by putting the mixture into the molds, so the mixture, once it's mixed to the consistency of builder's mortar, these 8 molds would be filled to within about 2 centimeters of the top. So you leave the 2 centimeters to be able to get the goodies in. The goodies are the ones which are listed. So it's magnetite, DNA material. So actually household dust is quite a good thing, because a lot of that is from the human body. But diatomaceous earth, shungite, some local soil from outside, graphite, honey, and cannabis. And most of those are in the form of powder, so they can just be mixed together. So you mix enough together, and it's a very small quantity, really. And you just mix that together, ready, and just enough to do the first 8 with the molds. And then Mike mentioned to me a method which has been great, actually, which is to use steel wool. So steel wool enables you to create a base onto which to put the goodies. So once the mold is filled to within 2 centimeters of the top, the first piece of steel wool goes in and is pressed into the cement, and then that forms the basis on which the goodies can be sprinkled. So that mixture of dusty granules and things is sprinkled onto the steel wool. And then I usually add a small piece of quartz crystal, a piece of amethyst. I sometimes put a little piece of shungite in there as well, and I have the quartz crystal pointing at the amethyst. And then once you have those, they're kind of embedded in the mixture of materials, in the sort of dusty mixture. And then it's just a matter of putting another piece. I put another piece of the steel wool on top of the goodies like that to protect them. And because Mike was saying the steel wool actually amplifies the effect, so putting the steel wool on like that, it can be cut with scissors, because you're doing it with quite small areas.
If you put copper or zinc BBs in that steel wool, there you got another source of piezoelectric energy. Just another trick.
Yeah, so we'd have the goodies in, and then it's a matter of just using a bit more of the mixture that we already have to top the molds up to the brim then, and we just smooth them off. You can just smooth them off with the back of the scraper, and then you just put them on the surface. I just usually leave them on the draining board by the sink, and you just leave them there. They probably need 3 hours minimum, but sometimes you can leave them overnight. But they would definitely need 2 to 3 hours.
Sorry, David.
Yeah.
Another point is that the mix should be pretty wet, okay, as opposed to being stiff.
Yeah,
definitely. And the reason is that as you get a better set on the calcium silicate that's produced during the chemical reaction,
yes, and
the water fuels the chemical reaction. Yeah. And so the more water, it sets harder,
yes,
to begin with, and it's more brittle.
Yes.
So it's not structural in that sense. We don't want it structural. We want it hard and brittle, because then it shrinks onto the goodies and the crystals and so on and so forth. That happens, much quicker. That's why that's how that quickset cement is set up to be used.
Yes, it rises to the surface, and it affects the strength of the mixture. But it's just trial and error, really. But it's as a guide, you want it so that it'll actually pour, but you want it so that it doesn't pour like cream. It needs to kind of pour slowly. And then what I just use a paintbrush like this, and once you put the mixture into each of the molds, sort of prodding it with the brush consolidates the concrete. They do this on building sites. They have these concrete pokers, and it's basically to get the air out of the mixture. So if you get a paintbrush and you put the mixture into the molds, and then you sort of poke it a few times with a paintbrush, that ensures that the mixture fills all of the mold, and then you get a nice clean mold with no gaps in it or anything. So you'll then have 8 of these molds, which is the first stage. And then, so the next stage is to actually coat them with the resin so that they look like this. And to coat these cones with the resin, you don't need to worry about doing the bottom at the first stage, because the bottom of the 3 cones can be done at the same time. So this one, what you do is you buy some, it's called Regal floor paint. There's the tin I've been using. It's called, yeah, Regal floor paint. They're based in Stafford in the UK. So you have a 5-litre tin of paint like that, and then you have the activator, which comes like this. So it's a ratio of, well, it's 20% of activator to the mixture for the 5 litres. So it varies slightly depending on the weather, because the activator, if you're doing it in the winter, for instance, it's going to be a longer process than in the summer. It tends to go off more quickly in the summer. So the way you mix that is you'll need some gloves. So I just have an ordinary pair of gloves like this. I do the coating of the cones outside. If it's a fine day and you know it's not going to rain, then you can just do it outside. I actually have a table with a parasol over it, so that if it's likely to rain, you can just put the parasol up and keep the keep the cones dry underneath. Because if the cones are coated and then they're rained on, then you'll need to do them again, because it disturbs the activation of the resin. So the resin, actually, it needs to be fairly small quantities. It goes quite a long way, and you just need a container like this, a plastic container. So you mix the resin. Well, actually, you stir the resin first. So you stir the resin in the large 5-litre tin to make sure all of the material is evenly distributed, and then you pour some of the resin into the container, and then you add the correct ratio of activator. And when you're doing this, it is worth wearing some protective eyeglasses, some gloves, and also a face mask, because the fumes from it's fiberglass effectively, so it's it's pretty ferocious if you breathe too much of it. But if you're outside in the open air and you've got a mask on, it's absolutely fine. To do the 8 of the pine cone molds is actually quite a small quantity, and then so the way you coat them is you buy some brushes. They have these, probably seen these brushes. They're quite cheap, really. You have sort of 10 brushes for £5, and because the brushes can only be used once, so you buy these cheap brushes, and then you just use them once, and then just wrap the brush in some kitchen roll and put them in the bin. So the way you coat them is, so you'll be wearing gloves, and then you just dip the brush into the mixture, and initially it's good to just paint the bottom kind of inch of the cone like that, so that you've got the whole of the bottom area coated, and then you can actually stand it up on the table. What I tend to do, I use usually a bin liner, and I open the bin liner up, spread that on the table, and then as I coat the cones, you coat the bottom of them first, and then you place it on, and then you can finish it off once it's sat on the table. And it doesn't matter if the resin drips down onto that bin liner, just like a piece of thin plastic. The thinner the better, really, because you can just pull it off once the resin's dry. So you just coat the 8 of those. Usually leave them for 24 hours to dry. Sometimes they take a little bit longer than that. And then that's the first stage done. So that's the
David?
Yeah.
Is this not the amplification layer with the iron oxide in it?
Well, yeah, the iron oxide. Yeah, the iron oxide is added on this amplification layer. Yeah.
Don't you mix that in with the resin when you
yes,
paint it?
Yes. Yeah.
Oh, I see. Okay, yeah.
So
Yeah, so it's about 50-50 iron volume wise, resin to iron oxide plus some binite sand or well,
yes,
that's it, binite sand.
yeah,
Binite sand is phenomenal. It doesn't take very much. You
yes,
know, teaspoonful, that's it.
yeah,
You know,
exactly. You
yeah.
you have to just be careful in the things that you're adding to the resin not to weaken it, because otherwise it can, break down the process.
Binite sand is sand that has been frozen and thawed 3 times. Because it starts emanating this blue light, as a result. The way that we prefer to do it, especially for the pine cone part and the goodies, is to take our best source of sand, which is normally whatever local sand, and then put it in a mortar and pestle and grind it up really fine, and then bionize it. You see, crushing the sand puts a stress on the crystal, but bionizing it takes the stress out of it and makes it phenomenal, really. All these things create spin energy, and that's going to harmonize with our DNA, all DNA.
Yes.
So,
yeah, putting some additional DNA into the goodies is a good thing, like putting some hair in or something like that. So yeah, but really, the technicalities and the sort of refined details are in Mike's paper. What I'm trying to do is just to steer people through the process of actually building them, so that there's no trepidation, that it's just a very easy process. So once you have the 8 of these cones with the layer on them, then you're ready to go with the next stage, which is the second cone, which is these. So as Mike says in the paper, these cones, that they're used for kids, really. They're mainly for playing football. You sort of set them up in that way. But so you get the smaller cones. What I do, I use this is damp-proof membrane, which is it's just really thick plastic, and you just form this to go into the cone, and that means that when you come to take the cone out, once it's set, it comes out easily. If you try to set the cone in this plastic without any lining, it sticks to it, and then you can only use the cones maybe once or twice. So excuse me, getting some damp-proof membrane, which is just thick plastic, you can get it from builders merchants. You just form that kind of insert, and then what I do, I just use cling film. So you just get a piece of cling film, and you put the cling film onto the thing like that, and then put it inside, and then when you pour the concrete into there, pour the mixture into there, and then that keeps it, so that it's very easy to remove once the concrete or the mixture is set. As you can see, I've put a piece of insulating tape on the join in that plastic, because if you don't do that, you find that the mixture seeps behind the plastic, and then that distorts the cone. Whereas if you just put that piece of and this applies to this second cone and to the outer cone, with the insulating tape like that, it just seals the plastic, and then you're ready to go again. So the way I do these, I actually just use a large plastic jar. You probably heard one of them break a few minutes ago, but if you have a jar like this, it's just like a pickle jar, really, and if you put this on a level surface, then you just have it ready to put the material in. So to do the second one, you have the first cone at the ready. You do the mixture as you did before with the 3 components. So you have the cement mix, you have the iron filings, and you have the water, the crystal water, or whichever water you wish to use. Mix them together, and then this time, so you put some in. I tend to sort of fill it up half first of all, and then again prod it with a paintbrush handle just to get it to compact into the shape of the cone, and then top it up. But you top the cone up to within probably half an inch of the top, to allow for the displacement when you push the first cone in. So you'd have So you'd have the cement up to here, have the mixture up to here, and then you want it so that as you drop the cone in, that it just sits level to the top of the cone. What I tend to do with the center cone is I usually cast 2 of these at a time. You can actually have maybe 2 or 3 of them set up. If you have a few of these molds like this, you can have them set up so you have the DPM insert in there ready so that it can be used. And then it just means that you don't waste the mixture, because you can just cast the 2, and then if you have some left over, then you can do, say, a third one as well. And so you can do with the middle ones, you could probably do 8 in a day if you had the two, if you were going to devote the whole day to doing them. The pine cone has been pushed into the top. Then they can just be left to set for 2 or 3 hours.
And the thing is that we're working with the ethers, and and the cone connects to all kinds of ethers due to the shape. If you can imagine, different etheric realms are a different size, and you got a cone poking up through there. It's going to fit perfectly with a number of them. So, and the anu is the physical thing. Everything has an anu around it. So all of this adds up to having precise sizes of things. The amazing part is this is a predetermined technology, because those cones that you've got there that are cheap and commercially available are the exact right size, 9 inches. Same with the pine cone forms from Amazon, the silicone pine cone forms, are 3 inches. It wants to be a little bit more than that. 3.3 is ideal, but 3 inches is really fine. And then the next one, the final one, the large one, around 14, 15, 16 inches is, because you're going into larger ethers, and you've got they adjust in size. And then you also into the larger swarf in the third layer, the third cone, so that you're literally dragging the really fine information out of the pine cone and broadcasting it into all etheric realms.
Yes.
This is why the cone shape is so powerful, and particularly being in the perfect harmonic size with the etheric realms that we're connecting up with to do our intentions. That's how our intentions get, first of all, established in darkness, like everything is. It's the smallest, finest level. And then it expands and grows as the ethers grow.
Yeah.
And then our ideas grow until they pop into the hexagonal ethers where they're made manifest. So there's 4-sided ethers right outside of darkness, and ideas come out of darkness, get installed into the 4-sided ethers, and then they broadcast up. We do the exact same thing with these cones, especially with these triple cones that properly made, set around the corners of the relevance chamber. But those triple cones are not necessary. Any organic thing will work. It's just in a triangle. You can do it on a slab. You can take a violet ray wand, poke 3 holes in an equilateral triangle on a concrete slab, put wire into it, and wire it to the violet ray wand, and you'll have yourself a very usable Merlin's chamber. However, the ones that we're doing are interdimensional doorways, or delta T antennas. The big tetrahedrons with the pipes and everything set up properly.
So when you push the pine cones in at the top, you do it upside down, right?
Yes.
So the top. So when you turn them back up, the top is facing up.
Yeah, that's it. Yeah.
Okay. Right.
And how far do you push?
You push them so that the bottom of the pine cone is level with the finished surface of the second cone. So it's just so that you have as it is with this. That's the base of a triple cone. So when you can see the 3 cones in there, but
sorry, a better idea, my friend, would be to push it further into the cone,
right?
So it's got a good bit of concrete all around it that squeezes it. That's what we want. That's what that's how we get the juice out of the pine cone.
Okay.
So I would put it further in, into the middle of the pine cone.
Great.
I mean, the next cone, the pine cone, will go further into the second cone.
Okay. So and then it can be covered over. And does that apply to the second cone into the third cone as well, Mike?
Yeah, of course. Yeah, because you're getting it's like feeding one turbocharger with another.
Yeah.
It's,
Yeah. Great.
you're gonna create some pressure.
Okay.
That's what we want, this pressure to squeeze the goodies and all of the sand, the bionized sand.
So
Sorry to interrupt. Is the bionized sand part of this mixture that you're putting in the second cone, the 9-inch cone?
If you want to make real powerful ones, you use always bionized sand. It doesn't have to be all ground up with mortar and pestle. Especially after you get the third one, it can just be sand off the beach to freeze off a few times.
you could actually cast 8 of the second cone with the 8 pine cones. So then you would have those 8 ready to be coated with the resin and then the amplification layer. So you just mix the resin and the bionized sand in a container. You get it, so that it's the right consistency, and then again you coat it outside. So you'd use a bigger brush for the second cone, and then you coat the bottom half of the cone, and then stand it up, and then finish coating it when the cone's the right way up. And then you just have those placed on a table outside. Put them on a piece of plastic or something, as I mentioned, like a bin liner, which is quite flimsy. The way to do though is make sure that the corners of the bin liner are weighed down, because you don't want the corners to be blowing up in the wind and then sticking to the pine cone as it's going off. So you just coat them in that way. So yeah, the second one will be coated, and so you could either do 4 or you could do 8, depending on how much time you have. So you then have it. You'd have them to the second stage, so you'd have 8 of the cones complete, ready for the next one, for the larger cone. And it's actually the same process there. So it's just mixing the stuff. As Mike said, it's beneficial if the iron filings that go in the outer cone are slightly larger. The ratio stays the same, Mike, doesn't it? It's about 30%.
Yes, sir.
So it's possible to add slightly bigger material for the outer cone, and they're just cast in the same way. So the same process as with the middle cone. You get the DPM polythene and you just form it, and then again you have to take into account the displacement of the second cone being pushed into it. So to leave it so that the level, that it's lower down. And you need to, with the outer cone, you need to just agitate it a little bit to make sure that you've got the best possible surface. You can tell the consistency of the material by whether or not the second cone will kind of float in it. Because if there's too much water in the mixture, then the second cone would sink into the third one. Whereas if it's the correct mixture, it tends to just kind of float, or it sort of bobs up a little bit. Sometimes you need to put a little weight on just to kind of push it down. And as Mike was saying, getting it beneath the surface, that's another little way to enhance it, really.
Yeah, you can make a bit of stiff stuff and put in the bottom that accepts the stiff concrete.
Yeah.
And you put that in the pointy end, and then the pointy end of the other one won't sink through it. Then you can put the loose stuff around it.
If it's pourable, but not stiff, then it will take the weight of the cone, and it's quite easy. You'll find after you've done a couple of these mixes that it's fairly easy to do. I've not actually lost any of the cones as a result of the mix not being correct, because you just have this intuitive feel as to it being the right mixture. Because if it's too wet, it's sloppy. If it's too stiff, then it won't go into the shape of the mold correctly. But so at that stage you'd have the outer cone, so that's formed, and you just put the outer cone into one of these large glasses, and just make sure that as it's setting, just look at it from both angles to make sure that it's level, because you want it so that as it sets, the base of the cone is level. If the cone isn't level in the jar, you'll find that you get a bit of an angle, and then the cone won't sit upright. That's why it's preferable just to do the outer edge of the three cones and leave them outside, and then you find that they'll be dry within 24 hours. To paint the bottom of the cones, what I do is I lie the cone down on the table so that the base is visible. But because you've actually coated the cones and they're in good condition, then you need to kind of wedge them so that they're apart. So if you were going to coat the bases of, say, 4 cones at the same time, then you need to just wedge them and keep them apart, because if they bump into each other, they can chip. So you need to just make sure that they're, you know, use some little wooden wedges or something just to make sure they can't bump into each other. And then you just you do the 4 bases at the same time then.
Yeah, I don't know if this will work, but after you get the amplification layer sets up, if you just put 1 layer of cling film on it and hit it with a blowtorch so that it turns black, okay, it's real quick.
Yeah.
It creates a nano coating, and that nano coating is the same thing as GANs, okay? And now the problem with these nano coatings is that they fall off easily, you know. But for the first 2 cones, encased in concrete, ain't gonna go anywhere. And more spin energy, basically. That's the nano coating creates microtubules in the carbon, and that leads to herself in darkness.
Yes.
That's why nano coating. You nano coat a piece of metal, and it will actually draw electrons out of the air into the microtubules that are the same size as DNA. And the way that you know that is because they're superconducting. Yeah. And so the electrons will go to a superconductor before they go to ground. So they'll go into the DNA spin of the nano coating or GANs or the piezoelectric energy that we create. And that they then are converted to photons. Because that's what flows in a superconductor. And then it comes out the other end and it runs into another conductive material. It has to convert back to electrons. And so you get a continuous production of electricity. The nano coating metal, like I say, it then produces a little bit of electricity forever as long as maintaining the nano coating. Yeah. It's just really thin plastic, doesn't take much. You don't want to have to heat it for very long or anything. Just hit it with a blowtorch so it goes black. Because otherwise, you heat it too long, you may hurt the resin underneath it. Yeah. We're putting it on resin as opposed to this is something that you want to see if you can do it, and also see if you can feel it. Obviously, I mean, it should be easy. Your pine cones are quite powerful, and so you just try it once on one of your pine cones, you're going to tell right away whether this is a useful trick.
I've not had any problems with any of the structures, doing it in the way Mike advises in his paper. The cones actually adhere really well, so that there's been no breakdown, and the Screwfix rapid setting cement is very strong, so you shouldn't have any construction problems really. They do stick together.
Mike, would it be a good idea to put GANs in the resin coating when you're mixing it up?
No, not really.
Okay, so I've got I've been just gathering information about how other people are building these cones, and there's a lot to do with the consciousness you imbue them when you're making them. Yeah. You should have that right frame of consciousness. Yeah. Also to play 33 hertz music or tones.
Yes.
And things like that in the background. Also to give each cone a name and create a connection with each cone.
Yes.
And I really resonated with that when I was reading. I think there's these people in Arizona that are building the triple cones, and they play music to it. Sometimes they chant to it. Whatever your way to communicate with them to imbue your consciousness in the cones. So I know this may be going out to people that aren't so much into that, but I would suggest just get the right kind of music. We're now creating a body of music with the Merlin's trance music that can be played as these are being constructed, because you're creating an entity for these cones.
Yeah.
Got a question for Mike. It's a bit of an advanced question because I'm trying to max out my cones. So I've got this idea for the small quartz crystal inside the pine cone. I've managed to find a couple Vogel cut quartz crystals that are about 4 centimeters long. And I'm wondering, so there's this idea, if you put piezoelectric pressure on a Vogel crystal, it will make its life force amplification power a lot more powerful. So I have an idea to like wrap wire around it and then have the wire come out the top of the cone, something like that. So Mike, what do you think about that?
Yeah, I would put that wrap crystal underneath the goodies, so it's pointing into the goodies. You know, and carrying spin energy into the goodies, and wrapping it with copper wire is a good idea. You can take that copper wire and come out of the cone, and it can come all the way out, you know, through all of the cones, and hook it up to a violet wire on. That's not a bad idea at all. You know? Yeah, and then you know, 4 centimeters is a bit long. You only need 2.2 an inch max. You know. Well, and then you have a little bit of.
It's really hard to buy short Vogel crystals. Like the smallest ones I found are 4 centimeters long, but I'll do some more digging there.
I've had lots of them. You know, I got a whole bag of them here. You know,
but
they're cheap.
Vogel cut.
They're clear. There. Clear. Well, this I just get regular, naturally shaped, you know, clear quartz crystals, reasonably clear.
But if they're cut at these specific angles, they're considerably more powerful. Have you heard
well,
of,
if you want to do that, you know, what's his name? You know, if you want to get into that, you go into Marcel Vogel's crystals.
Yeah,
that are cut lovely.
That's what I'm talking about.
Well, okay, properly cut, like you're talking about, that's going to work quite well.
And if it's 4 inches, that it shouldn't matter because it's properly cut. It doesn't matter that it's that big.
Run them by again.
4 centimeters.
Yeah, it doesn't need to be that big. What I found with the natural quartz crystals, you just take a little clear quartz crystal. You know, it's kind of like almost like a shard. You put it in your left hand, and it'll almost like burn a hole through your left hand. You know, you can feel it. Now, those are the kind of crystals I like. And then I take graphite and a little dab of honey. The honey being having a hexagonal nature forces the graphite into graphene, you know, which is 2D, which is a connection to God, you know, herself and darkness, you know, because it's made out of carbon. And you put a little tiny bit on the truncated end of a natural quartz crystal, and you can feel the power of it. I mean, it's amazing, you know. And you put that underneath the goodies because it's going to keep going forever.
And the difference between amethyst and clear crystal, it sounded like in the goodies you want both. What's the difference between them?
Amethyst is a cleansing crystal, and that's when you get this is what's his name? Carl Wells is really a good orgonite. He invented the name orgonite. What he talked about, and his devices are very powerful, is to never have anything over the size of a grain of sugar in any of the pieces. But the problem with those really, really fine pieces is that they clog up with information. It doesn't travel, it doesn't move out. And the amethyst, apparently, amethyst and citrine move it out, causes it to keep moving.
Okay, here we go with what I believe will be should be the bog standard pine cone for an avalanche of these things going in the water. Okay, so the beating heart of each pine cone is these BBs, 2 dissimilar kinds of BBs, with this ground up amethyst, citrine, Martha dust, and the fine sand, all ground up, mortar and pestle. It's got the little bit of, take a little bit of that, you put it right on the pine cone, on the BBs, and that will amplify it. The BBs are dissimilar metals. They will create piezoelectric energy. That piezoelectric energy will be conducted through the steel wool. So this will go inside after I fill this up mostly. Then you have to shove this down inside. You can't put it in there and pour it on top. It doesn't work. It'll float out. Then I will put a little mirror over the top of them. Okay? And the mirror comes from this, and this stuff is really cheap. It's mirrored mylar, and Little Tyke has mirror all around it on the bottom. This is a CD that's a mirror, and the Little Tyke's super powerful. I use the plumber's mortar and red iron oxide, and I happen to have some titanium oxide that does amazing things, and some brass filings that I put in. There's the BBs. This is a pine cone that I made. I tried to stick the honeycomb on the cement, which doesn't work. You got to glue it on later. The honeycombs will go on later. This needs epoxy in order to go in the water. And then you put this on the epoxy, and the epoxy will hold it on there. And you put one little tiny bit of raw honey in there and slap it up there on the epoxy. It'll be there forever. Now, then you'll have to coat it again and have another layer of epoxy over the top of that to protect it from the water, because that is beeswax. It'll melt. And here's a really fine wool. This water has CO2 GANs in it, which is what you want. That's what heals the water. It's got orgone and crystals and all kinds of stuff in it. And that's it. Now we'll do it.